Hello students. Today we are going to understand the third practical on a virtual lab for the electrical machine 1. So recently we had gone through the two practicals in which in first practical that was related to the familiarization of the of the electrical components in a virtual laboratory, and second one was the load characteristics of the DC motor. So now we will go for the next one. Okay, so for that we will go first of all to the VLab. So you can simply search on VLab. Here you will get the link virtual lab, and in that you just click on electrical engineering. So here you have to go for the IIT Roorkee. Okay, this is the electrical machines lab name. So I clicked on that, and now we are at dashboard of electrical engineering, electrical machines. Okay, so now the important thing is we need to understand about means which are the practicals already we had seen. In that, these first two practicals we already seen, right? These first two practicals we had already seen. Hmm. So in that we had seen whatever be the machine laboratory apparatus are there, that we had seen. Then second one was about the load characteristics of DC generator, and now we will understand about the speed control of DC motor via speed resistor control, and another one we will see armature resistance control. Okay, so let us go for the first one, that is a field resistance control. Okay, so once we'll go for that, here you should click on this. So once you will click on that one, it will take you to the experiment page, and here you can see the aim to study the speed control of DC motor by field resistance control. Draw graph between the armature current and motor speed by varying field resistance. Okay, so that means you have to control the speed of DC motor. How? By varying the field resistance. Okay. So, and you have to draw a graph for the armature current versus motor speed. So, we'll see the theoretical part. So, as we all know that here, whatever be the speed of the DC shunt motor, that is given as, we can write here N is equal to V minus IA RA divided by K phi. Okay, so if suppose I will keep all the above terms as it is constant, okay, and will just vary the fluxes. So what will happen if I will only vary this term? What will happen? So that whatever be the process that is going to happen, that we will observe. Okay, so means if I will vary my current, then my obviously my fluxes will get changed. Means suppose if there is a fixed supply voltage and our motor that is connected as a shunt, then what we can do, we can vary the armature voltage. How? By controlling the external resistors which was connected into series. Okay, so now here the speed control can be achieved by varying armature resistance, I told you, and then again another, that is field resistance. Okay, so for now we will see about the whatever be field resistance is there, that we will see. So here you can see in the figure that whatever be the resistance, that is, see, this is the armature. See, this is the armature. I can write here armature. This is the field, and both are connected in parallel. That is why it is called as a shunt, right? So now in that shunt, we can see this is the varying, we can see rheostat is connected. So by varying this resistance, we can change the value of current flowing through this. Okay, so we are changing current flowing through the field. That means we are going to change the value of fluxes. So as we know that N is equal to V minus IA RA divided by K phi. If suppose my current is going to increase, means see, whatever it may be increase, it may be decrease, but if my current is going to increase or decrease, obviously my fluxes are going to react. So once my fluxes will react, what will happen about speed? Means if my flux is increasing, my speed will come down. If my flux is reducing, my speed will go up. So that is all about the theoretical part in a speed control of DC motor with the help of, and this will be the ideal graph you can see. So let us go for the pre-test questions. So see which torque is greater. Okay, so here you can randomly click on the question answer. Following motor definitely has permanent magnet. That will be your homework. Okay, so to eliminate the fifth harmonic, then again full page to the coil. Speed of three-phase induction motor is controlled from 1 to 2 per unit using a variable frequency inverter. Then equivalent circuit parameter to vary is. So what will be correct answer? That you have to tick here and you have to submit the quiz, and also you share the results with me. Okay, then we'll see what is the procedure exactly. So here as procedure is given, connect all dots in the following manner. So you can write it down on your page and see A to K, A to Y, A to J. What is this exactly? So that is given here. That is the panel, or you can say this is the connections you are going to see on virtual lab. So let us take a jump to the simulation page. So I am taking you to this page, and here you can see, let it load. Okay, so hold for a second. Yes, now it will be here. So here you can see that I'll just zoom in so you can be able to see everything clearly. So okay, it is fine, I think. So you can see there is a sorry, there is a, then B. Okay, so these are the terminals for your simplifications they had mentioned here. Okay, then P, Q, R, I, J. So alphabets that has been given to connect or to make connections properly. Okay, so what you have to do, you have to click on whatever be this. Here also if you click on this instruction, it will shows you what is the first stage, that is A to K. What it is saying, connect A to K, A to Y and A to J. So let us connect. First we will make connection A to K, A to Y, A to J. So A, click here, A to K. Where is a K? Here is a K. A to Y and A to J. So this A part connection has been done. Then next B to P and E to M. B to P, okay. Then E to M. Where is your E? So there is your E to M. So how it is, means the what they are exactly doing, that whatever negative terminal that has been given to here, okay. And then F to D. So where is your F? F here, and F to D you have to give connection, that is means here at a motor level. Okay, then G to R, H to I. G to R, so here is my G and that will be here, G to R, and H to I. So my H will goes to voltmeter. Okay, then I to C, C to H. See, I to C and again from C to H. Okay, that is very simple. Okay, you have to only follow the instructions. Q to L. So this again one terminal should be connected here. Now see, all the terminals has been connected. Okay, and you can see that time you have to check the connection. Once you will click on the check button, that will shows you accurate connection. Okay, then now first stage check, we will click on check. Okay, so correct connection, proceed to take reading. So that is giving me a correct sign. Okay, now next step is what? Next step is that if it is showing alert as incorrect connections, then press reset button and make connection again. Okay, if it is showing correct connection, then turn on MCB. Now I'll turn on the MCB. So you just see how this red light will become green. So that means I had turned on the MCB. But whether I had given voltage, not. Still now I have not applied any voltage. So what we will do, then set the voltmeter first with the help of second slider. Where is the second slider? So I'll show you. Okay, second slider means this slider, armature resistance slider. Okay, so what we will do, we will set the voltage. See, this is 220 volt. Okay, so 220 volt we have set it. Now move the first slider to get corresponding values of ammeter and speedometer. Now see, still I have not given this one, so I'll just take it that one. Okay, so see, my motor is started, my current is showing. Okay, now you can see my motor is rotating. So I want to take these readings. So what I will do, I'll click on the add to table. Okay, and you can see here my observation table is automatically generating. Okay, then I'll just add one more. See what will happen. 2. I have increased resistance. Then see speed. It comes down. It comes down. So I'll take click on that add to table. Okay, then again third reading we will take, that is for 4. Okay, again my speed comes down, then again I'll click on add down. So here see, your current and your speed are adding in table. Then again I'll click on one more, it's 5, and again I'll click on add table. I will take more readings. Okay, so add to table. Again I'll click on one and add to table, and now we will stop. Now we will stop. So like that way we will take a readings only. Okay, so now I'll click on this off. Sorry, first of all I'll take it to the this one. So see, that time your motor is now 0. I'll reduce my voltage. Okay, no issue. Now you have to plot a graph. Now whether you are already visible to this graph, not this graph is not visible to you. So what we will do, we'll click on this plot. So how this plot will become, it will be speed versus current. So see, once I'll click on that plot graph, you will get a ready-made graph also. So you can click on print and your print will be automatically come like that way. Okay, once you will click on the print, it will becomes like that way. I will save that one into my drive. Okay, so you also can save. Here I'll go to the Swiri E and I'll make a new folder, that will be em1. Okay, no issue. And in that we will type speed field resistance control of DC motor. So we'll save that one. That will be the PDF. So that is all about the experiment. Okay.